let's balance. Let's do this. Okay? Let's balance this equation. Okay, this type of problems are really standard. They're more or less, if you know how to do one, and you understood how you do the process, it's really the same all the time. So, well, let's answer the questions here actually, instead of doing it the free way. It's going to be a little bit restricted, just answer the questions the problem has. So here we have an equation that represents a chemical reaction. And it says which element is being oxidized, which is being reduced. Well, to answer these questions, we need oxidation numbers, right? Otherwise, you're going to do it. So, in order to do that, we assign oxidation numbers. So, bromine has what? Routinely, we put oxidation numbers below. That's what this picture does. Because the charges go on the top, and if you put them together, especially if it's the same color, you will be really confused. So it's good to practice to put charges on the top, oxidation numbers on the bottom. Bromine, an element, oxidation number, 0, and goes to -1. Okay, and manganese is 2+, right? +2 goes to how much? +4. Right? Okay, so which element is oxidized? To be oxidized, we have increased, algebraic increase of oxidation oxidation number. So which one is algebraic increase? +2 to +4, right? So which element is being oxidized? Then the answer is manganese. Which element is reduced? Well, right? Right, the balance oxidation have reaction in acidic solution, okay? So we want to balance the equation that represents the oxidation, right? So which is oxidized we said? Manganese. Okay, so we're going to go from manganese to +. I give space here, otherwise you will be not doing good. You will get sloppy and then you will have wrong result. So you give a lot of space here to be able to move around. And now manganese 2+ goes to manganese dioxide. That's it. Now we want to balance this. So when we have such an equation, half reaction, right? We balance everything else, every element, except hydrogen oxygen. So manganese is already balanced by mass, one manganese. And then we go to the next, which is oxygen, by using molecules of water. So we have 2 oxygens here, plus there are 4, how many of waters? 2 molecules of water, so I have 2 oxygens that way. By doing that, I introduce hydrogen. And I have to balance the hydrogen now. So I have 4 here, there's nothing here, there's nothing here, so it's 4 hydrogens. So I'm going to put 4 hydrogens in what form? Protons. Great. So that's balanced by mass. Now, I'm going to balance by charge. By doing by charge, the electrons are so small mass, it does not disturb the balance by mass. So it doesn't really care what I'm doing with electrons. But 50 electrons on one side, not on the other, it doesn't matter because they're so much small mass, it doesn't disturb the mass charge, the bottom ones. Okay, so we have +2 here, and we have 4 plus here, right? +4, +2. Where I'm going to put the electrons to make it the same? I'm going to have to put them here, 2 electrons. -2 + 4 makes +2, which is the same thing like that. You agree with that? Okay, so it's balanced by now it says in acidic solution. Well, it is an acidic solution, isn't it? When you see that H+, means by definition that's what we mean, okay? And then it says write the balance reduction half reaction acidic solution. Well, that's pretty easy actually. really nothing there to do, more or less. So the reduction will be bromine. Molecular bromine goes to ionic form of bromine, which is Br minus. Okay, you balance over A elements, so it's 2 here, you put 2 there. We don't have anything else to balance by mass, we're done. We balance by charge. Remember, you have minus 2 here, and so you need minus 2 minus charge there, you put 2 electrons. One way sometimes to check things if you're doing right or wrong is that the electrons, if this is oxidation and this is reduction, if one is here and one is the other is there, the electrons are in opposite sides, okay? So for one half reaction has the electrons on the left, the other one has to have them on the right, okay? You cannot put electrons in both, reactants in both, right? Because when you add them, they will not cancel out, right? So we have 2 electrons, that's an easy problem actually. When you add them, right, the electrons are going away. So if you add them, this goes away. So what remains is, but it says in basic solution, so, you know, what I'm going to have is balance overall reaction, right, in acidic solution, because I'm going to have H plus. So if I add this, we have 2 electrons, I don't have to multiply by a certain number to make the electrons equal, because they're already equal. So I just add them, the 2 electrons go away from each side. This is manganese 2 plus 2 waters. You stop at there or right there. You go here. You start up to here. Br2, manganese dioxide, 4H plus, 2 Br minus. Okay, now that is in where? In acidic environment. It's just basic. We want basic. So we don't want H plus. Why we don't want H plus? Well, if we want basic, H plus, in fact, aqueous, because we're talking about aqueous, but we don't have to write it down to waste time and get confused with too much writing. The reaction of H plus and H minus, in fact, hydronium ions, really, not this one, but just for simplicity, we write just H plus. H plus and H minus gives you water immediately, right? You cannot have H plus around if you have an equivalent number of OH minus. It will make immediately water. So if it's a basic environment, we don't want that H plus there to be there. So what do? We add the same number of hydroxide ions in both sides. So you add plus 4 hydroxides, plus 4 hydroxides. Doesn't matter where you put it, doesn't matter. By doing that, I don't disturb the balance of mass or charge because I put the same exact chemical species and amount in both sides. But these 2 things here, they actually make 4 water molecules, right? So all this is actually 4 water molecules.
We can't see that.
No, you can't. Right? And that makes 4 waters. Why? Because 1 and 1 gives you 1. Some students have problem with this. 2 with 2 gives you 2. 4 with 4 will give you 4. Yes? Right? Okay. So 4 waters and 2 waters. These 2 go away, raise it really good, so you won't make a mistake, and this 4 becomes 2. So if you do that, then you come up with the solution, which is going to be what? Bromine. Manganese dioxide plus 2 bromide ions plus 2 water molecules, right? Right? That's it. Don't miss this kind of problems. Right? The standard solution, really. Same thing with the previous one. There are standard problems we put in the finals. You should not miss this problem. How about if you miss them? What will happen? You get upset with yourself. If you get upset with yourselves, the next hour you will get upset with your parents and with your friends, and you will feel guilty and really bad. So try not to get upset with yourselves first. That's the easiest thing to do.